Hello viewers, in this video I will talk about the equation of path of projectile as an application of Rolle's and mean value theorem. But before proceeding further, I would first like to give some details about the equation of path of projectile. And in the next video I will talk about that how we can discuss the equation of path of projectile as an application of the Rolle's and the mean value theorem. Okay, so the equation of motion for a projectile launched with an initial velocity v naught at an angle theta from the horizontal is given by x equal to v naught cos theta into t and y is equals to v naught sin theta into t minus 1 by 2 gt square. So when we eliminate t from the equation, we obtain the parabolic form of this equation. So this is a well-known equation. Um, Okay, so in the projectile motion, the highest point of trajectory occurs at the peak height where the vertical velocity component becomes zero. The projectile starts from y equal to 0, which is the launch point, and again reaches y equal to 0 at the landing point. Since the function y is continuous and differentiable on the interval 0 to r, so here we consider r as a range, horizontal range, and since y0 and yr both are 0, Rolle's theorem guarantees that there is at least one point C where the derivative of the function becomes 0. So this occurs at maximum height h where the derivative of the function becomes 0. So this x becomes h. So when we solve this equation, we have x equal to v naught sine 2 theta into g. And when we use this x in the original equation, so when we back substitute x in the y, then we immediately get y is equals to v naught square sine 2 theta over 2g. So we have this fixed point at maximum height and which can be written in this way. Okay, so before proceeding further, it is first useful to visualize the equation of projectile motion. So we define some constant. For example, v naught is the initial velocity. We define 3 and g is equals to 9.8, and we can calculate the maximum time which has already been given in the equation. So this is 2 v naught sine. For example, we consider first the angle pi by 6, then we can calculate the numerical value of the maximum time. And the parametric plot is a useful command in which we use the two equation of motion v naught cos theta into t and v naught sine theta into t minus half gt square. So we write these two equation as x-axis equation and y-axis equation, and we write theta equal to pi by 6 here, and the time considered starting from 0 to maximum time. So maximum time can be obtained from this situation, and this is the plot range, and plot style is red thick, and we apply some frame, and the frame label can be written in this way, and rotate label is false. And further, this is another useful command to see a very effective graph, and the plot legends is pi by 6. So when we shift enter, we get this parabol form of the projectile form equation, and this graph is plotted for pi by 6. In the similar way, we apply for theta equal to pi by 4 and obtain this graph. And similarly for theta equal to pi by 3, we get this graph. And when we combine these three graphs, we get this output. And we can see that at theta equal to pi by 4, we have maximum horizontal range. And but we have uh, almost same range for theta equal to pi by 3 and pi by 6. So the maximum height can be achieved at theta equal to pi by 3. Thanks for watching.